Now I've intentionally introduced the vocabulary, if you will, of this language that we're developing, along with the rules for forming meaningful expressions, as it were, in this language, in a rather meaning neutral way, with the exception of my labeling the uppercase letters A, B, C, and so on. Sentence letters, there should be nothing in the way in which I've introduced this vocabulary and these rules that suggests how the language that we're developing is to be used, although of course there's no hiding the fact that it appears in a presentation on logic, so we can assume that the theory at issue is a logical one. But let's put that in abeyance and focus purely on the formalism without going beyond to associate any meaning with these symbols thus far written. I will say first of all that we're able to write well-formed formulae in a list. We'll list them, we'll make these lists vertical, and we'll number each line in the list like this. And we'll come on to fill in these lists. And the rule is that I'm going to use is straightforward. And that rule is that if a with alpha appears in the list, my writing, by the way, is atrocious, so you'll have to forgive me. And, moreover, if a with alpha arrow beta appears, I'm just going to put ditto marks in the list, then we can add beta, the with beta, because the assumption here is that both alpha and beta are withs. We can add beta to the list. So that's straightforward enough. If we have a list, let's write it here. We have a list, the first line of which is alpha, and the second line of which is alpha arrow beta. Then, by the license that we are given by this rule, we can add to the list beta. Simple enough. Now, let's have a look at how, I'll just take that out, at how we can apply this. Let us suppose that we have a list comprising these withs. We'll say it's alpha, and then we'll say that we have another with alpha arrow, and then there's a beta here, and our beta is this with, which will be alpha arrow something, and that something is going to be another with alpha arrow beta. So here we have a with. It is a with because it can be formed by an application of our formation rules. We know that alpha is a with, and therefore alpha arrow beta, this is our beta here in this case, is a with. This beta is alpha arrow this, closed off parentheses, and this is indeed a with by virtue of the fact that open parentheses alpha arrow beta, where alpha and beta are withs, close parentheses is a with. So this is indeed a with. It's formed by multiple applications of the rule according to which if alpha and beta are withs, then open paren alpha arrow beta close paren is a with. Now, what can we make of this? Well, how can we continue, if at all, this list? Well, we have alpha and we have an alpha arrow a beta, so we can write in virtue of this rule, by the license that this rule confers upon us, the beta. What is our beta in this case? Well, our beta is this. It's open brackets, alpha, arrow, this bit, and then close brackets. So we can write, in virtue of lines 1 and 2, open paren, alpha, arrow, alpha, arrow, beta, close brackets, close brackets. And that again is because this is of the form alpha, arrow, beta, and this is our beta. And so we can write that beta here. Now we have an alpha and an alpha, arrow, something else, the beta. So we can write, again, by the license conferred on us by this rule, we can write that beta. This time that beta is this expression. So let's write that down. Alpha, arrow, beta in parentheses. Now what do we have? Well, we have an alpha and an alpha, arrow, beta. So what can we write? We can write down, by the license that this rule confers, the beta. And what is the beta? Well, it's simply beta. Can we go any further? Is there anything else? No. Now this rule here I am going to call an inference, or the inference rule. And for the purposes of propositional calculus, as we'll now call it, that is the only inference rule. And we sometimes call that particular inference rule the rule of, in logic anyway, modus ponens, which we'll sometimes generally abbreviate to MP.